Hey there friends, how's it going? And welcome to my tutorial for the Niagara UI Renderer plugin for Unreal Engine. I will be working in Unreal Engine 5, but the same steps should apply in Unreal Engine 4, so feel free to follow along. In the last episode we made this really cool looking mouse trail particle effect, and in an episode before we created this button dissolve effect. Today I want to tackle something a little bit more advanced. Currently, when I play this game, I can collect these coins, but they just disappear. I want to make a Niagara effect, so they will bounce around the screen and bunch, and then they will fly to the top left corner of the screen, and when they reach this coin on the top left, they will count as collected. Let's start by creating a new Niagara particle system. Let's right-click, go into Effects, and create a new Niagara system. As always, we will choose New System from selected emitters, and we will choose a simple sprite burst as a template. Let's call it Niagara System Crystal Collect. Let's open it up. And first of all, let's replace the sprite render default material with our particle crystal material. Okay. So for the basics of this effect, we need to always spawn new particles at a place where we collect the crystal in the world. We could do the same thing as last episode, so we would move the actual widget into the location. But this time let's try doing something a little bit different. This time let's try sending the actual position into the Niagara system, and it will spawn the particle at the correct location itself. We also can define how many particles we want to spawn on each of these things. So we will also need to send information about how many particles it should spawn. Let's start by that. Let's create a new user exposed variable, and let's call it the spawn count. Of course, it will be integer because we don't want to spawn like 5.5 crystals. We always want it to be a whole number. So let's use that in the spawn burst in whatever that thing is. Okay, so let's just use it here. By default, this will be set to 0, so we won't see anything, which is not really good. So let's just, for testing, crank it up to something like 10. Okay. When we spawn these particles, I want them to burst out into all directions. So let's just add a velocity to them. And let's do some random velocity in range. Maybe from something from like -100 to 100, and z can be always probably positive. So like 50 to 200. Okay, and let's also apply gravity force, so they will start falling down. Okay, let's maybe just increase the initial upwards velocity a little bit, so 200 to 500. Yeah, I like that. So now we can tell it from Blueprint how many particles we want it to spawn, but we cannot tell it where we want these particles to be spawned. For that, let's use a sphere location model. And let's have some small sphere radius, maybe something like 50. And we want to have this sphere origin not to be at the particle's position, so not at the origin of the world, but rather we will specify this also with blueprint-driven variable. So let's add new user exposed vector, and let's call it maybe spawn location. Spawn location. Okay. And let's use that as the sphere origin. Okay, now let's try this particle system in our UI widget. I already have this UI widget where I only have this horizontal box with an image and a text box. but we don't really need to worry about it. Let's just add a new Niagara System widget into our canvas panel, and let's make it fill the whole screen. Okay. In the Niagara System, we will choose our crystal collect particle system. We will populate the revamp list, and I think I already have a UI version of my crystal material. So now we can see those particles in the top left corner. Because remember, we told it to spawn at 0, 0, 0. And currently, this is the place where the 0, 0, 0 is. Okay, for this, we will need to get the location of the actual actor that we collected. So let's open the pickable crystal. And in here, we have already an event that currently just destroys the actor after the animation is finished. Instead of just destroying the actor, let's do something a little bit different. In the crystal UI, let's go into our graph. We can just delete this thing that's already there. And let's create a new custom event. And let's call it crystals collected. So this will be the event we will call when we collect our crystals. Probably what we will need is an integer input, which will say how many crystals is collected. And the other input will be a vector input, which will say where we collected those crystals. So collected location. Okay, I'm adding this widget through my HUD. So over here, what I can do is just get my HUD. It will be probably in the player controller, if I'm not mistaken. And from here, we can just get the HUD and cast it to my BP of the HUD. So cast to BP HUD, and this is the blueprint where I'm spawning this crystal UI. Also, we can take a look at it. In this blueprint, I'm not only creating the widget, but I'm also storing it into a variable crystal UI. So we will be able to access it later. And we will do it right here. So get crystal UI. And from here, we can just call the crystals collected function we've created. And we can destroy this actor afterwards. So currently, when we overlap the component, which is just the sphere around this coin, it will just play this animation to go up and do kind of popping animation. And after that, when the animation is finished, we will get our HUD, which has stored a crystal UI reference to this thing, and we will just call the crystals collected. So obviously we need to tell it how many crystals and where they were collected. So for that, for number crystals, let's just create a new variable. We will just call it number crystals. It will be integer, and let's expose it to the editor so we can actually edit it on per instance basis. And also set some default value, something like 4 crystals. For the location, we can just get our actual location and add 150 on the z-axis. I'm just doing that because that's where our coin will end up after the animation is finished. If you're not animating the coin to go like up and down or do something crazy like that, you don't need it. Just plug in the get actual location straight into there. So if we go over here into our crystal UI, this thing should be firing. So let's just test it out. So we will just put 2 print strings over here, plug one thing there, the second thing over there. And now if you play the game, when I collect these things, you can see on the top left, it's probably not visible very well because it's blue and my coin is blue. So let's make it like bright pink. So we should be able to see that, oh, I should fix that, that we actually send this data around. Okay, Now we will need to pass this data we get over here to our Niagara widget. So for that, let's go into our designer and let's just rename this system so it's something more sensible, like Niagara System crystal collect particle. Okay, and probably let's also, because by default we don't want these particles to be spawned. That gets spawned on the top left. These ones over here. So let's do something like this. When we pre-construct this widget, let's just go into let's get our particle widget. Let's get a Niagara component and let's set the integer. It will be, set Niagara variable by string, and we want to set an integer, which we called spawn count, and we just want to set this to 0. So by default, it will spawn just 0 particles, so we won't get the initial burst. Okay. And when we collect some crystals, we want to basically do the same thing, but this time, instead of setting it to 0, we will set it to actual number of crystals we want to spawn. And we also want to set the location. So we can just go straight from this get Niagara component and set a Niagara vector3 variable. We call this one spawn location. So it would be tempting to just plug this one straight in, but if we did it, it wouldn't really work because this is actual world location. This will be the location relative to the screen. So we somehow need to convert this world location to our screen location. For that, there's already a node in Blueprint. So if you right click, we can just untick context sensitive, and it's called project world to screen. Over here, we will need a player reference. So just stick back in the context sensitive and get owning player. That's exactly what we want. And it also wants the world position. So that will be the position we're passing in. Okay, after this, it will give us the screen position. But that's still not the position we want to plug in here, because there's a bunch of scaling applying to screen, right? When you're playing the game at 720p and 4K, there is some scaling that's happening to your UI, so the elements are correct size. So what are we going to do for that is just let's split this structure pin and let's get the viewport scale. So this will give us the actual scale our UI is scaled by. And if we divide these two values by it, we will normalize the position, and this will be the actual position we care about. So now we can just make a vector for this. And we could try plugging the X into X, or the screen position X into X and the screen position Y into Z. Remember, Y is the depth like into your screen, so we will skip that. But this won't really work. If we play now, they won't spawn at the correct location. Also, they won't spawn currently at all, which is another problem. But the reason why they're not spawning at the correct location is that if you try to print string this value, once again, let me try making this something like orange. Okay. We can see that if I collect anything, that the Z is positive. And the way I made this plugin is that the top left corner of your screen is 0, 0. And if you imagine looking at the world at 0, 0, if it's on your top left, if you go down on your screen, the coordinates will become negative on the Z. So we just need to flip the Z to negative numbers. So just multiply it by -1. Okay. And now we will get the correct spawn location. Currently, they still won't be spawning. So for this, let's just reactivate the system. Because if you remember here, you're just spawning the particles at frame 0. This particle system will activate once, and then it won't reach frame 0 ever again, right? So that's why we need to reactivate it, because if we reactivate it, it will go again from the frame 0. Also in the emitter state, let's tell it you will be loop just once, and the loop will be infinite. Okay. So after this, let's just get this reference once again, and let's tell it activate system. And we want to reset it, so we'll go from frame 0. Now, if everything works correctly, we should be able to go to the particle, to the coin, and when we collect it, we can see that bunch of particles spawn over there. Okay, that's starting to look good. One thing that's irritating me is this menu UI. So let's just remove it from no one needs menus, right? No one cares about menus. Okay, don't look at this. There's nothing ugly in there. It's fine if it's not part of the tutorial, okay? Don't judge me. Okay, so now we don't have the menu, and the particles are spawning at the correct location. I would like to increase the Z velocity at the beginning because it's just really abrupt stopped over there. So let's go into our Niagara system, and when we are adding velocity to them, let's also decrease this timeline to like 2 seconds so we can see what we are doing. And let's add the initial velocity to like 1000 to 2000. Okay, so now if we collect them, they should really burst out. Okay, that's maybe a bit too much. 750 to 1250? I don't know, maybe something like this. And let's increase the sphere location a little bit, so they will actually cover the original coin better. Oh, that's way too much. Okay, let's decrease this. Something like 20 maybe. Okay, now they're spawning at the correct location. So the other part we will need to deal with is, first of all, how to get them to count as collected when they go to the top left, and also to bunch around the screen, and also to get to the top left. So these will be the things we'll handle next. So let's start with just counting those coins as when they're collected. For that, we can use the Niagara particle callback handler interface that's already integrated in Unreal that allows us to send data from Niagara to blueprints. So we will actually send that data, so we will detect if our particle died in our particle system, and when it died, we will send the data to the blueprint. And because we will give our particles some lifetime, it won't really matter if we will kill them when they come to the top left, or if they die by getting out of lifetime. So even if some particles by chance bug out somewhere else, player will still get them counted as collected. So it won't break a game, which is always good. For that, let's go into our Crystal UI widget, and let's click on class settings. Over here, if we scroll down in a details panel, there is a section for interfaces. Let's add a new one and just search for Niagara, and there should be Niagara particle callback handler. This is an interface which allows Niagara to communicate with blueprints. I think if we just search for Niagara event, we'll get event receive particle data. So this will be the event our particles will shoot out of. So now we have it in blueprint, but we need to call it from Niagara. So let's go into our Niagara system, and in particle update, there is thing called export particle data to blueprint. That's the one we want. And we can see that it needs callback handler parameter. This is basically just a reference to the blueprint which it should send data to. So let's make the reference as user exposed. I think object, yeah, object, that should be good. And let's call this our interface object. Now let's just copy this, and over here we can just select the interface object, and let's go over here, and we need to set this interface object to reference of this widget. So we can do it in pre-construct. So as we were setting the integer 32 for the spawn count, we can also set Niagara variable that's an object. It has named the interface object, and the reference will be just self. So we will just tell it, send all the data to us. And just to make sure it's working, let's just print string just the length of this data, so we will know how many particles we've collected. Let's make this orange, and let's put a quick little append in here. So you've collected, and then the number. Okay. So there's a checkbox called condition to export data. Basically, if we just checked it, it would send all the data from all the particles every single frame, which is not exactly what we want. We want to send this data only when they're dead, right? Only after we kill them. So for that, we can just do condition if they're alive. But we want the exact opposite when they're not alive, right? So we will just do not operation and then alive over here. So we will send the data only when they're not alive, so after they died. Okay, let's try that. So if we play the game, I will just collect this thing, and now as they die, you can see we've collected 4 of them. They died at the exact same frame, so that's why it just told us we collected 4 of them. If we set their lifetime to be a bit randomized, right? So something like from 5 to 10 seconds, or for the demonstration purposes from second to 2 seconds, now we should get 4 separate events, and you can see them up there. Okay, so this communication works. So what we can do now from here is basically just count this as collected particles or collected coins in our case. So let's create a new variable that we will store how many crystals we've collected already. So let's call it just crystals. It will be integer, of course, and by default it will be 0. Yeah, that's good. And every time we collect the new crystal, so let's add a for each loop here. So this for each loop, this data is just data from every single particle. You can bind the data to it over here, so you get 2 vectors and 1 float. But we are not going to use this since it doesn't really matter what the position or what the rotation of the particle was. We just care about that it died, and we will count that to our num crystals. So we want to just increase this integer, and after it's increased, we will go to our text box and we will say set our text, and we will set it to our number crystals. Okay, just give me a second to make this nicer, because Blueprint run up to 10 times faster if you manage them correctly. I don't know if you know that. That's a total lie, by the way. just kidding. Okay, and let's play the animation for add crystal. This is just a small bump animation I've made to make it look nicer. It looks something like this. It's just, you know, a visual feedback. Okay, let's try that. So now, every time any of these particles dies, it will get counted on the top left. So if you keep an eye on the counter on the top left, they will increase as our particles are dying. Okay, that's one thing taken care of. Let's do the other thing. So we want our particles to go to the top left, right? So they will be attracted to the counter. For that, we will just use a point attraction force. So let's add that to our particle system. And we need to tell it where we want our particles to attract. So for that, let's create a new vector variable, and we will call that target location. And let's use it over here. And the attraction strength should be pretty big. Let's try like 1000. And the radius should be maybe 200, 500. Okay. It's kind of weird, like they're stepping over there. Yeah, but this should work. So now in our crystal UI, we need to tell it where the target location is. So we can probably just set it. So the problem with this is that the target location can change. If we have a game and we maximize it or change the resolution of it, the location where those particles are supposed to go will also change. So we should dynamically update where our particles are going to. For that, let's just create, in construct event, we will create a timer by event, set timer by event. And we will just repeat this every half a second. You should probably, if you want to optimize this, have a callback event. So if player clicks on set resolution button or something like that, then and only then you would update all these values. But I just don't want to deal with it, so I will just update it every half a second. So let's create a custom event, and we will call that update particle data. I don't know. Yes. So we want to update the target location. Let's get our particle widget. From there, let's get the Niagara component. And from that, we want to set vector variable for Niagara. We called that target location. And once again, we need to calculate where the target location is. So what we know is that we can get the reference to the actual image of this crystal. This is just reference to this image I have on screen. And from this, we can just get the cached geometry, which is just all the geometry for drawing the UI that has been cached from previous rendering. And from that, we can just call a function that's called local to viewport. And for this, we can just give it local coordinate, and it will give us the pixel position on screen. So the local coordinate, we basically just want the center of this thing. Because if we didn't give it any local coordinate, just 0, 0, it would give us the top left. Because this is 57 pixels by 57 pixels, we want to give it something like, let's have that is like 28.5. But of course, the image size can change. So let's just get a reference to the image or this one, and just let's get desired size, and we can just divide this by 2. So we don't need to worry about changing the size of that image. And do update it automatically. So let's do 2 and 2, okay. And let's plug it in as a local coordinate. We are just interested in pixel position right now. So let's split the pin so we will get separate X and separate Y. And let's make a new vector for this output variable. Okay, and for this, once again, it depends on the viewport size. So the same as before, we will get the viewport size, or the viewport scale, not size, and we will just divide both of these. So we will normalize them to be always correct values. And once again, we will multiply the Y or the Z by -1, so it will get inverted. Okay, so now if we set up everything correctly and we will go into our game, now when we collect our particles, they should be attracted to the top left. It doesn't look like it's doing much, so let's go over here and let's increase the attraction radius to like 4,000. Because I think currently they're just out of the radius of the attraction force. Okay, that's not exactly what I expected it to do. So what's wrong? Oh, okay, I'm stupid. So instead of setting the attractor position, which I should have done, I've set the positions to attract to our target location. So this should be the particle position because that's the position we want to attract, and the attractor position should be the target location. So it was doing basically the reverse thing, and it's also the reason why it looked here so weird. But now, when this is fixed, we should be able to just go into the game, play, and we can see them flying to the top left. Okay, that's starting to get the effect I wanted it to have. Let's maybe decrease this force a bit and remove the fall off exponent. Okay. So currently it starts attracting immediately after we collect this particle. That's not really what I want. I said that I want them to bounce around a bit and just after that to be started attracted to the target location. So for the attraction strength, let's, instead of just straight putting this number here, let's do a multiplication. We will just keep the 600 in the A or the 800. And from B, we will put a curve over there. So over life of the particles, we can specify how much it should attract it to our target location. So at the beginning, I don't want any attraction, so I will just leave this to 0. And I will leave this at 0 to maybe like 0.25 seconds. And after that, at like 0.75, not seconds, but this is the normalized age, I will put this up to 1. So after that, they will get attracted there. And in the particles, I will let them live a lot longer, maybe from like 15 to 20 seconds. Okay. So now they shoot up. They bounce around a bit, and after that, they're attracted. Okay, also currently, just so we can see it better, we can test out more particle spawning and even test if this thing works. So let's try spawning like 40 of them. Okay, so we collect 40 of these, they fall down, and after that, they should start to get attracted to the top left. Of course, probably we currently don't see it. So let's fix that and make them actually bounce from the edges of the screen, because that will help the effect a lot. So what we can use for that is a collision module in Niagara. We won't do the ray traced collision, but we will do analytical planes instead. So we can tell it where the planes are, so the edges of the screen, and it will automatically bounce around. So let's tell it we will do 2 collision planes, and let's do the top edge of the screen first. So the top edge is at 0, 0, 0, so we can set the plane position to be 0, 0, 0, and it faces down, so the collision normal should be -1. The left edge of the screen is also 0, 0, 0, but it faces right. So it won't be Z, but the X will be set to 1. But the bigger issues is with the right edge and the bottom edge, because we don't know where they are, because that can change depending on the screen resolution. So let's just duplicate this collision module. And instead of specifying these values right here manually, let's create a new vector variable that will be called bottom, bottom right. Okay. And we will use that for both positions. But now we need to change the normals. So for the bottom side, it won't be -1, but positive 1, and for the right side, the x will be negative 1. Okay, now our particles are stuck over here because they don't really have much to do since they're spawning already at 0, 0, 0. So in the preview, let's just try spawning them at like 400 and negative 500. Or 800 and negative 800. It seems like there's... Oh, of course. Currently, they cannot move because the bottom right is set to 0, 0, 0, and the top left is also set to 0, 0, 0. So just for testing, let's do bottom right 1920 by 1080. So now, if we look at this thing, also negative 1080, of course. They will spawn, bounce around, and let's increase our preview time. They will spawn, bounce around, and after that they will be attracted to the top left. Cool. So let's set those variables from our UI. We will continue setting those variables over here. So it will be set Niagara vector variable. And we've called it bottom right. And let's calculate those. For this, we can just get the viewport size and once again the viewport scale and do the same thing as always. So let's just split the structure pin and let's divide those. After we've done that, we can just make a new vector for this. Of course, multiply the y by -1 or the z and connect it up. And if I've done everything correctly, this should give us a really nice looking bounce effect. If we collect one of these things, they will bounce around the screen. And after they're bouncing around, they will go to the top left. Okay, this starts to look like the effect I wanted to look like. Also, let's just move this widget to the top, so it won't be behind. Oh, not in the horizontal box. I just wanted to be over here. Okay. Wait, what happened to 0, 0? Okay. So now they should be in front of the top left widget. Yes. So the next thing we want to do, we don't just want to wait until they die, right? We want them to die immediately after they touch the top left thing that's already in there. So let's implement it. For that, we can just kill particles. And let's put it on top. And we want to kill those particles that are close enough to the target location. So for that, let's do a float comparison. And we want to compare if the distance between our target location, so let's subtract target location, and the current particle location. So this will give us distance from the center of our particle to the center of the target location is less or equal than, let's say, 50. I don't know currently how big the widget is. We will need to probably tweak this variable. But now they start bouncing around. And after they touch the top left thing, they immediately get killed. And that just counts them as collected. Okay. Let's try tweaking this effect just a bit more to make it look a bit nicer. So first of all, the point attraction force. Maybe let's lower it a little bit, something like 600. Also, the initial velocity on the x-axis, let's try just increasing that a bit so they will spread around more. And also we can play around with the bounce values. So currently, when they bounce, they lose 0.4 of their velocity. So Let's maybe do half of that. Okay, let's try that now. Okay, they spread around much more. And then they go to the top left. Cool. Maybe I would add a drag force over here. Just to dampen the initial velocity just a bit, something like 0.5. And let's increase the gravity to like negative 1500. So they have like a bit more weight to them. Okay, they bounce around. After they bounce around, they go to the top left. Also, currently you can notice that they don't go fully down on the ground. They have like a few pixels offset. That's because the material I'm using isn't completely from edge to edge, but we can just go to the collision and set the radius scale to be something like 0.6. So let's try that. We will see if this improves the effect. So this just, we tell it, oh yeah, those particles are smaller than you think. And yeah, that seems to work nice. Maybe even a bit more, maybe like 0.4. Okay, that's a bit too much. Okay, 0.5 will be the golden middle way. So also one thing I want to try doing is, I don't like how they're currently all just coming up and then down. Maybe it would be cool if some of them had like inverted gravity, so instead of sticking to the bottom of the screen, they would stick to the top of the screen. Also, I think the 0.6 was better. So over here, radius scale. So let me put that back in and let's do that. So in the gravity force, we will do, how is it called? Select custom vector from bool. And we can just do a float comparison for the bool, and we will get our particle material random, and we can just compare it if it's greater than 0.5. So that should be like 50-50. And either it will have positive 1500 or negative 1500 for the gravity. So with this, half of them should travel up and half of them should travel down. And this is pretty nice looking effect, I think. So they like bounce around, then they stick around a bunch, and after that they get collected. Maybe they have too much different lifetimes, so let's try something like from 12 to 15, so they will be a bit more uniform, at least with this. Okay. Do we want to change anything else in this particle system? Let me try seeing this effect one more time. Okay, they bounce around a bunch, and then they go to the top left. Let me try decreasing the point attraction force even a bit further, like 300 maybe. Okay, they bounce around, and then they go to the top left. What if we enable the fall of exponent? Will that make it look better? What am I doing? Okay, here. Okay, and now let's increase the attraction force back up. Okay, go like this. And now they should go over there. Okay, I like this effect. I'm happy with this. So we can also change the number, but let us try if it's reliable. So if we collect all these coins, I think we should have 92 coins in our inventory. Okay. More coins, more coins. I want them all. My precious coins. Okay. And you can see we have just 88. So this is actually a bug I noticed just yesterday. And it happens that if we collect more actors, more of these coins at one frame, it still triggers the Niagara system just once. Because if we go into our crystal UI, we can see that when we call the crystals collected function, we just set a spawn count to some number, and then we call activate a system. But this doesn't spawn those particles immediately. This just tells Niagara, okay, next frame you're going to reactivate. But if we call this multiple times a frame with the same number of crystals, so 4, it will activate. Even if we call this 3 times with 4 crystals, it will spawn just those 4 crystals next frame. So we can do our little workaround around this. I'm not really a fan of this, but hey, if it works, it works. So instead of just telling it this is your spawn count, what you're going to spawn, we will create a new variable, which will be, I don't know, num spawn this frame. It will be 0 by default. And first, we will increment this value by the num crystals. So we will just add those two together. Okay. And we will use that. And next frame we want to reset it. So yeah, this will be a bit hacky, but I don't care. I will just add the delay at 0 seconds. And I will set number spawn this frame to 0. So if you don't know, the delay of 0 second is a delay that's exactly 1 frame. Because basically what's happening in the background is that you have the delay system. It sets the delay, and next frame it comes and it looks, oh, did it already pass 0 seconds? Of course, the answer is yes. So it triggers the thing that's after that. So sometimes even in some code, if you see multiple delays of 0 seconds just connected after each other, it's actually not pointless. This is, for example, 3 frame delay in blueprints. Okay, but back to the point. So now, if we play our game, everything should hopefully work fine. Of course, I don't want to forget any of these precious coins back there. I want all of them. Give me all of them. I want those coins. Oh, sorry about that, guys. I just get sometimes, you know, a bit obsessed with coins. Never mind. So now, when all of them will come to the top left, we have 90. There we go, 92. And I count it as a successful tutorial series. Let's connect all things back up. In-game, yes, you're not in-game by default. So our precious, beautiful cursor trail, our even more beautiful dissolve effect. And after that, if we collect these coins, they nicely go to the top left and count as collected when they hit the thing. Beautiful. Let's just make sure it works properly. So just for fun, let's take this horizontal box. Yes, let's put it into top right. And the alignment can be 1 and this can be -40. And let's just swap these things around. Just for fun, just to see if it works correctly. Okay, and last more tweak, because it's making me frustrated. Let's decrease this, if we go into our kill particles, this B thing to 40, because I think they were dying before they actually touched the thing on the top left. So let's try it out and see if our modular system actually works and if they will go the correct location. And they do. Cool. Okay, so I think our tutorial series was successful. So once again, guys, thank you very much for watching. I hope you enjoyed this and maybe learned something. I hope you will have a nice day. Talk to you later. Bye bye.